Hello once more YouTubers, welcome back to my YouTube channel. This is Mr. Uncle Pythagoras signing in. Today we are going to continue with the previous question papers to answer it with you so that you can get a more understanding of how do you apply your skills to brighten your paper. Right, we are through with question 1.3. Now we are going to question 2.1.1. Question 2.1.1. It starts like this. Question 2. Question 2 it says the following is an arithmetic sequence. 2.1.1. Calculate the value of P. If you are given the sequence of P, let me put my P here, of P, so that I will use this one as a sequence. 1 minus P, 2P minus 3, and P plus 5. Right. They say we must calculate the value of P. So it's 2.1.1, and then it says that calculate the value of P. Here we can find the value of P by saying the common difference is equal to term 2 minus term 1, which is equal to term 3 minus term 2. Our term 2 is this one. It's 2P minus 3 minus term 1 minus 1 minus P is equal to term 3, it's P plus 5 minus term 2, it's 2P minus 3. So here you continue with your 2P and minus 3, multiply a negative into a positive 1, it's negative 1. A negative times negative P is positive P is equal to P plus 5. A negative times a positive 2P is negative 2P. A negative times negative 3 is positive 3. Now we're solving for P. Take P on one side, which is 2P here, plus P. Take this P, this side, you minus P. You take this 2P, is negative. When it comes this side, it's going to be positive. 2P is equals to, you have a 5 plus a 3. Now you take your 3, it's negative, this side is going to be positive. You take your minus 1, this side is going to be positive 1. Then a P and P cancel one another. You have 2 plus 2, which is 4P, is equals to a 3 plus 3 is 6. A 1 plus 5 is 6. 6 plus 6 is 12. Then your P is going to be 12 over 4, which is the same as 3. Now you have calculated the value of P, and that was worth how much? I will check later. I don't have it with me here. Right, we're coming for question number 2.1.2. It reads as follows. Write the values of A, the first term of the sequence. B, the common difference. Right? You answer A as follows. A is the first term. You come back from the common difference. Our common difference is going to be 3. Our common difference is going to be T2 minus T1, which is our T2 is 2P minus 3 minus T1, it's 1 minus P, which is going to be 2P minus 3 minus 1 plus P. We have 1 plus 2 is 3P minus 4. The value of P was 3. You plug in your 3 minus 4. 3 times 3 it's 9 minus 4. 9 minus 4 is 5. The first term is the common difference, the first term of the sequence. The first term is going to be T1 is equals to 1 minus P is equals to 1. Your P is 3. 1 minus 3. Yes, it's 1 minus 3, which is going to be minus 2. Your B wanted us to find the common difference. The common difference already we have calculated it here. Here is our common difference. D is equal to T2 minus T1, and up until you find your D to be 5. Now we go for the next question, 2.2 or 2.1.3. 2.1.3 says, explain why none of the numbers in this arithmetic sequence are perfect squares. Now let's find out T1. T1 was found to be minus 2. T2 will be 2p minus 3. 2p minus 3, which is p was 3, 6 minus 3, which is 3. T3 is 1, it's p plus 5. P plus 5. Your p was 3 plus 5, which is 8. Then the sequence is minus 2, minus 2, 3, and 8. We must find out, explain why none of the numbers in the sequence are perfect squares. A perfect square is a number that is multiplying itself. So when you take 1 squared, you are going to get a 1. When you take 2 squared, you are going to get a 4. When you take 3 squared, you are going to get a 9. When you take 4 squared, you are going to get a 16. So if you check, minus 2 is none of the perfect square numbers that I have just illustrated here. And 3 does not fall under the category of a perfect square, as well as the 8. So explain why. Because none of the numbers when multiplied by itself will give a perfect square. Will give a 1, 4, 9, 16, and so on and so forth. So the next question is going to be, we are going to look at the sequence and series by looking at the quadratic sequence and see how do we deal with the quadratic sequence. That will be dealt with in the next video, so keep subscribing and liking so that you will see all the videos that is going to be uploaded for you. Thank you very much. Uncle Pythagoras signing out. Have a great day.